I have something else to show you with these beautiful colored bead bars. There is something in mathematics called the commutative property. I wonder how many of you know what that is. Well, the commutative property is applied to addition and multiplication, and I'm going to show you how we introduce it to our 4 and 5-year-olds. Okay, here we've got a problem. It says, or an equation called 4 plus 3 equals. Let's get our beads out. 4 plus 3 equals 1, 2, 3, 4, 5, 6, 7. 4 plus 3 equals 7. Well, this is kind of funny. It has a rubber band around it. I wonder why. Let's just take that rubber band off. Oh, there's another equation. This one says 3 plus 4 equals. Let's try that. 3 plus 4 equals 1, 2, 3, 4, 5, 6, 7. 4 plus 3 equals 7, and 3 plus 4 equals 7. They're both 7, so let's just get rid of one of those answers, and that's all we need. If you look at that, 4 plus 3, it's just the same as 4 plus 3, except it's reverse, isn't it? And this is called the commutative property of addition, that you can turn the different addends either direction that you want. So here's our paper for writing the commutative property. So our first problem is 4 plus 3 equals 7. And our second equation is 3 plus 4 equals 3 plus 4 also equals 7. So you can see that having these little prepared cards or tickets for children to write on, they're easy enough to design on your computer. You just print out a whole stack of them, and children just love to work this way. So now we've seen the commutative property in addition, and this is plenty for one day with your child, but later on when they're doing multiplication, I just want to demonstrate how the same thing works with multiplication. Always slow and gentle in your movements and showing children how to work with the material, knowing their absorbent mind is taking it all in. And that care that you take with the material is something that will come along with them, as well as the things that you want them to learn and memorize. So now we've got a multiplication problem. I have my avenues of math color-coded, or the operations of math color-coded. I might at this point have yellow felt out, but we're just going to go with this. So our first problem is 3 times 4, and we read that as 3 taken 4 times. So let's get 3 bars. 3 taken once, 3 taken twice, 3 taken 3 times, 3 taken 4 times. Okay, and what does that add up to? Let's see if we can multiply. Maybe the child has done skip counting with chains. Maybe he needs to count all the beads. Either way, I'm going to skip count. 3, 6, 9, 12. So our answer is 12. So 3 taken 4 times equals 12. Well, again, this is one of those things where there's a little rubber band on the equation. Let's take that off and see what we've got. Oh, okay, now we've got 4 taken 3 times equals. Let's see what that is. So now we take our 4 bar. 4 taken 1 time, 4 taken 2 times, 4 taken 3 times, 4 taken, whoops, that's all I need. Okay, so now if the child can skip count, 4, 8, 12. If you can't, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 taken 3 times is 12. Oh, now look at this. 3 taken 4 times is 12, and 4 taken 3 times is also 12. So we only need one of those answers, don't we? So let's see if we can then have papers to write it. We have our commutative property paper for multiplication. So we can write both of our equations. 3 taken 4 times equals 12. And our second equation is 4 taken 3 times also equals 12. Now there's another little thing that you can do. It's a little tricky to do, but it's kind of fun. You can show the children that if you pick these up, if you've got a small equation like this, you can do it. This, if you could lay this on top of these beads, just turn it sideways and lay it on top of these beads, you'll see that it's the same. Geometrically, it's the same. So there's a lot going on with the commutative property of multiplication. Again, you can reverse the two features of your equation, and you're going to get the same answer. So one of the many things you can do with these beautiful colored beads.